Hi, this is our Unit 4, Day 4 set of notes on parallel and perpendicular lines. The big thing to know for parallel and perpendicular lines is we care about the slope of our lines. Any lines that are parallel, and remember, parallel means that they are always the same exact distance apart, they will never ever cross. Any two lines that are parallel have the same exact slope. They have the exact same slope, so if we can find the slope either by looking at an equation like this one, y equals 2x plus 3, the slope is 2 here on my upper line, the slope is 2 on my lower line. Slope is the same, then my lines are parallel. So that one's super easy to see when you are looking at what the slope is. Perpendicular lines, you want to compare their slopes and you want to see opposite reciprocals. So let's talk about what opposite reciprocals are. We are going to imagine that we have some sort of a fraction as our slope. So if my original slope on my first line is -3/2, then a perpendicular slope will be the opposite sign, so it will now be positive, and it will be the reciprocal. So we're going to flip that fraction upside down. Okay, so -3/2 was an original slope. The opposite reciprocal is +2/3. Okay, and another way that you can just double check that you have opposite reciprocals is if you multiply those two together, you will get -1. So if you find two slopes on two different lines and multiply those slopes together, if your answer is -1, then your slopes are perpendicular, your lines are perpendicular. All right, so here are my slopes right here, -3/2 on this line and +2/3 on this line. They cross at a right angle. This is 90 degrees. That is the word perpendicular. It means that they are crossing at a 90-degree angle. All right, so we'll do some examples. If I'm looking at y equals 3x plus 5, first, I know my original equation here, my slope is 3, right? So a parallel slope has to be exactly the same. Any other line that has a slope of 3 is going to be a parallel line. If I want a perpendicular slope, I need the opposite reciprocal. So I'm going to think to myself, 3 also is 3/1. Now I have a fraction. A perpendicular slope is the opposite reciprocal. So I need the opposite sign. It's going to be negative, and I'm going to flip that guy upside down, and so I will say -1/3. That is the slope of any line that is perpendicular to my original line. All right, so I'm going to take a quick pop over to Desmos graphing calculator just to show you what this looks like. Okay, so here we are in the Desmos graphing calculator, and I highly encourage you to play around with Desmos graphing calculator and change your slopes so that you can see what your lines look like. All right, so the line equation that we were just looking at is y equals 3x plus 5. So this red ball tells me that that is the equation for this red line. And we can see that we are crossing the y-axis at 5. And if we were to find 2 points that we're willing to work with, we can see that the slope for this line is 3. Just like we can read in our equation, the slope is 3. Okay, any line that has a slope of 3 is going to be parallel. So my next line equation right here, this is going to go through the origin. And when I turn that line on so that you can see it, you can see it's the black line here. It has the same exact slope, and we are going through the origin. The red line and the black line here, these two are parallel. They will never ever cross. They have the exact same slope. Okay, I'm going to turn off that line. Right after I remind you one more time that if we've got the 3, and we've got the same exact slope, those guys are exactly parallel. If I take the opposite reciprocal and use that slope, remember this is 3/1, so the opposite would be negative, and I flip it over, it's going to be -1/3. This equation, y equals -1/3 x plus 5, has the opposite reciprocal slope. You can see that we are crossing, it happens to be right here on the y-axis, and I'm going to have a perpendicular angle right there, 90-degree angle. You don't necessarily cross on the y-axis. It can happen anywhere. So watch, I'm going to change my 5 to a 3. I'm just going to move that line. Now the blue line, the perpendicular line, has moved, it's shifted, but you can see that it is still perpendicular to the red line. If I change it again to something like 2, you can see I'm just shifting it. I might change it to a negative number. Let's change it to -2. So every single time it has the perpendicular slope, the opposite reciprocal slope. So I am having a right angle when these two lines intersect, and they can intersect anywhere. It just happened that the first example I chose had them intersecting on that y-axis. Okay, and so just as an example, if I were to choose another line, y equals -1/3 x plus 4, this is now this upper line here, you can see that it is perpendicular to my original red line, right? My original red line had a slope of 3, and my now darker blue or purple line has a slope of -1/3. Notice that my two bluish lines are parallel to each other. See that? And notice in the equations, they both have a -1/3 slope. So of course we expected those two lines to be parallel to each other. All right, so back to the notes page. All right, this is the equation we were just looking at, y equals 3x plus 5. I know the slope here is 3, which I can think of as 3 over 1. Any parallel slope is always going to be 3. Any perpendicular slope is going to be -1/3. So we'll look at our next example. We have y equals -2x minus 10. The slope of this line is -2. Any parallel slope will just be a slope of -2. And so any perpendicular slope, I know that this is the same as -2 over 1. I need the opposite reciprocal, so it's going to be positive 1/2. Okay, and over here I have y equals 15x plus 3. My original slope is 15, which I know is 15 over 1. Anything that's going to be parallel is also going to have a slope of 15. Anything that will be perpendicular is going to have the opposite, so negative, and reciprocal, -1/15. All right, you have some more examples. Please try those next examples and then come back and check your work to see if you got the correct answers. So you can pause here and then come back and check. All right, if you check your work, you'll see that for problem number 4, your original slope is -2/5, so a parallel slope is also -2/5. The perpendicular slope, we want the opposite reciprocal, so we are positive 5 over 2. Number 5, our original slope right here is 5/4, and so that would be any parallel line would have that same slope. Perpendicular, we're going to have the opposite reciprocal, so change the sign and flip it upside down. For number 6, we had -1/7 as our original slope, so any parallel slope is also -1/7. For the perpendicular slope, I want the opposite reciprocal, so this would be positive, and then it's 7 over 1, which I just wrote as 7. All right, for these next problems, we're going to look and decide, are these lines parallel or perpendicular or neither? So we just need to compare slopes, right? If the slopes are exactly the same, they're parallel. If they're perpendicular, they're opposite reciprocals. If they're neither, they don't have the relationship of same or opposite reciprocal. I'll also show you what I mean. Okay, so y equals 4x minus 2, that slope is 4. Over here, y equals -1/4 x plus 2. Well, I see one is positive, one is negative, so they are opposites. And I have 4 over 1 and -1 over 4. These guys are opposite reciprocals. And that means that they are perpendicular. So we're going to say opposite reciprocal means that they are perpendicular. I hope that's what I just said 1 second ago. Perpendicular. Okay, if I look at my other two equations right here, 4x minus 3y equals 9, well, I have to figure out what the slope is there. My favorite way to find the slope is to put this back into slope-intercept form, which is y equals mx plus b. So I'm just going to do that. I'm going to solve for y. I have -3y equals -4x plus 9. I just subtracted the 4x from each side. Now I'm going to divide every single thing by -3. All I really care about is the slope, but I'll go ahead and finish this. I'll say y equals +4/3 x minus 3. Okay. My slope then is 4/3, right? If I slide up, I can write m equals 4/3. On this line, I don't have to do the math, and I can see that my slope is 3/4. These are reciprocals, but they are not opposite reciprocals. See that? They are both positive, so they can't be perpendicular lines because they're both positive. They're both the same sign. So they're also not exactly the same number, so they're not parallel lines. These two lines are neither. And you can always plug in these equations into Desmos and take a look and see whether you think that they are perpendicular or parallel. All right. Sometimes we're going to be writing equations of parallel and perpendicular lines. And so let's read through this question. Write an equation, this statement. Write an equation in slope-intercept form that passes through the point 2, 4 and is parallel to the graph of the equation y equals 3x minus 5. If it's parallel, those the LLs are parallel to each other, we know that our slope is going to be same. So I'm just writing same to remind myself. So I need the same slope as this line. The only thing I care about right here is that my slope is 3. Since I need a parallel line, I need a slope of 3 on my new line. Okay, my new line is going to pass through this point 2, 4. So I have an x and I have a y. We are going to use y equals mx plus b, and we are going to figure out the new line. All right, so what's the slope of the given line? It was 3. What's the slope of a line that's parallel to it? Still 3. Okay, so if I use point slope and convert to slope intercept, then I'm going to use the point they gave me and the slope that I know I need. I know I need my slope to be 3, and the point that they gave me is 2, 4. See that right up here, 2, 4. Okay, I have to write an equation in slope-intercept form. So I can write my equation initially as y minus 4. This is point slope form that I'm using. Y minus 4 equals 3 times x minus 2. Okay, I'm using point slope, and I'm going to solve for y so that I can put everything in slope-intercept form. This is y minus 4 equals 3x minus 6. And I'm going to add 4 to each side, so I have y equals 3x minus 2. This is my equation of the line in slope-intercept form that passes through point 2, 4 and is parallel to this equation. Try it out on Desmos, see if you believe yourself. Okay. I also could have used the slope-intercept form to find the y-intercept. Okay, so I'm going to back myself up and make sure you can see everything on here. I know that the slope for my new line has to be 3, and I have an x and I have a y. So I know slope-intercept is y equals mx plus b. If I have y equals 4, and I have m equals 3, and x equals 2, plus b, you can see that I'm going to, y equals 4, m equals 3, x equals 2, and I'm going to say plus b. I want to find that b. So I should have written here, that my point is 2, 4 instead of just pointing up higher on the page. This point 2, 4 is what they gave me. That's where I got that. All right, if I want to solve for b, I'm just going to solve this equation. 4 equals 6 plus b. Subtract 6 from each side, so negative 2 equals b. I now know y equals x plus b is really minus 2. And you can see I solved a different way, but I got the same exact equation.